Thanks for joining today's webcast, Find and Fix Bugs Earlier with Topaz for Total Test. We are extremely pleased to have as our speakers today Compuware Account Consultant Jim Young and Solution Consultant Yvette Santana. With that, I'd now like to welcome and hand things over to Jim.
Thank you, Janet. Good morning, good afternoon, good evening, everyone, depending on where you might be on the planet today. Welcome to this edition of the Compuware Did You Know webinar series. My name is Jim Young, and it is our privilege to host the discussion today focusing on finding and fixing bugs earlier in the application development lifecycle, with particular emphasis on automated unit testing. By automating unit testing, we will witness how developers can immediately validate incremental changes to code, thus reducing the risk of introducing slight defects into the code base that might not otherwise be caught until much later in the testing process, when, as we all know, much more costly to fix. Shift left is indeed a concept we see the industry embracing. Yvette Santana, technical consultant, will lead us through a discussion of automated unit testing and then demonstrate Topaz for Total Test, Compuware's offerings for automated unit testing. We will then have time to consider any questions that you might have. So we have much to cover. Let's get started. Yvette, I'll turn the microphone over to you.
Thank you, Jim. Again, this is Yvette Santana. I'm a solutions consultant that supports the Topaz suite of tools as well as the Expediter tools. And we're going to be talking about Topaz for Total Test and how we can overcome some of the challenges we have with our applications and testing. So some of the fears that we have associated with the application in working with our application COBOL code, it's just complexity. We normally don't have unit tests associated that we can repeatedly use. So we're doing ad hoc tests with them. There's also not very good documentation. Some of these applications have been around for a very long time, as well as the fact that we have some of the experts that are knowledgeable of the applications leaving the organizations. And then, of course, we also have some environmental constraints. So why should you automate unit testing on the mainframe? Right now, manual testing slows the development process down. That becomes the bottleneck when we're developing our applications. Creating unit tests is labor-intensive and time-intensive. So because of the number of programs that we're developing, creating these test cases can be time-consuming. This is why you must automate both the creation and the execution of these test cases. Automated unit testing has proven itself in the distributed world, and it can work in the mainframe world as well. We like to show this pyramid because, as you can see, the lower you are in the pyramid, the lower the costs are, the more reliable the application is as it moves up the pyramid. So the point here is we want to try to catch any of the defects in our applications in the lower half of the pyramid, which is in the unit testing. So what are some of the challenges we have with unit testing? Some of us are new to some of the applications that we support, some of these COBOL programs, so we have no visibility into these applications. The data is inconsistent. Because we don't have a set of data that normally we can use, that is a moving target essentially for us when we're running our unit tests. Availability of the subsystems like DB2 and CICS. These tend to get hit a lot during the testing process, and so those subsystems become problematic in terms of availability. Portability of tests and sharing of tests, and we can cover those with Topaz for Total Tests. So Topaz for Total Tests is a new approach to automated testing. We've introduced this automated creation of unit and functional testing for our COBOL unit test creation. It will also enable you to virtualize your I/O as well as your program executions. We provide functional testing within it, and it can be used easily integrated into your tool chain. So things like Jenkins, so that you can automate this process. And Topaz provides a plugin for Jenkins specifically to automate these components. So Topaz for Total Tests will leverage Expediter to collect the details about what the application does during the execution. Expediter is the perfect vehicle for doing this, because while you're in an Expediter debugging session, Expediter is fully aware of what your application is doing, what input he's using, as well as what output he's writing out to, as well as any called programs and any information that's being passed from one program to the other. So it makes it the perfect vehicle for collecting the details for your unit test case. We collect data such as QCM, VCM, DB2, your IMS, BMP, DLIs, MPP, as well as for CICS. And we'll also collect the information that's being written out to files or generated in reports, and we create these assertions for it. You will have the ability to also stub out or virtualize any of those components, both the data component as well as the program component. So this is a graph showing what you can do with Topaz for Total Tests. You can leverage Topaz and Expediter to debug your applications. Once you're comfortable with that application, you can generate that test case, and then you can move it up into your pipeline and automate this process once you have created a good test case for that application. So program virtualization is another piece of Topaz. We can generate these sub-program virtualization. So you might have these programs that are still being developed, and that would inhibit normally your testing of your application program. With stubbing or virtualization, this allows you to continue working on the main programs and testing them while the program is under construction. And once that program has been created or developed, then you can choose to run the test case without the virtualization of the subprograms and validate that the application is executing as expected. You can also change any of the data that's returned from these program stubs. So you have full control over the test case as well as the content within the test cases. So as we mentioned, data virtualization, we can isolate your subsystems once you create these test cases, such as DB2, IMS, and CICS, removing that dependency on those subsystems until you're ready to test with those live subsystems. Again, with Topaz for Total Tests, these are choices that we can make. The same is true with the files and databases. So we no longer, once the test case is created, we don't have that dependency, and we can choose to execute with the virtualized data or programs as well as the live data or programs. Another thing that we actually do in the total test case generation is we actually will create the assertions, the right assertions, or the comparison of the results when you execute your test case. Again, you have control over this. You can change the assertions to whatever meets your needs during the testing. So now we're going to show you a live demo of Topaz for Total Test. I'm going to launch an Expediter debugging session and show you how I can easily create a test case. And then I can turn around and run that test case and determine if it was a success or a failure. And then we will also show you a sample Jenkins pipeline in which this test case has been incorporated into it so that I can automate this process when I check my programs in during the development cycle. So here we have Topaz for Topaz Workbench. And as I mentioned, we leverage Expediter for generating these test cases. So I'm going to go in and go to my debug configurations. As you see here, I have several of them, but in this case, I'm just going to provide the JCL that I normally use to execute this particular application. So I would run this JCL outside of the Expediter debugging session just to execute this application. It has all the details it needs in order to execute. So I'm going to go ahead and launch that. And it will ask for credentials as well as put me into an Expediter perspective within the Topaz Workbench. And as you can see here, I'm paused at the very beginning of the program. And this is where I have choices. So when you right-click, this is one of the beauties of the Workbench, is that everything is a right-click away. I can select, or one of the options that are available to me is the ability to generate the unit test case. And I'm going to go ahead and click that. And this brings up a dialog about what it is that I want to capture for this unit test case. And so we're going to go ahead and create this unit test case. You can see here that I can decide whether or not I want to generate the stubs for the subprogram, and this is the virtualizing of those subprogram calls. The default is 100 calls that we can do here, but those values can be increased to meet the needs of the application that you're working with. We also have the ability to generate any IO stubs. So data stubs, in this case, BCM, QCM, I'm going to capture any reads or writes, and I also want the ability to for it to automatically create the assertions for those writes as well. And this application does have DB2, so I'm going to keep the DB2 stub collection checked. Again, these values can be altered to increase based on the number of calls your program performs. And I can choose to uncheck or check IMS. If it doesn't have IMS calls in the program, then it won't generate any stubs for it. And I can just say OK. And then just resume the execution of this program. So I've already prepared it, and it's going to go in and execute this program normally. I'm not going to actively debug it because all I'm trying to do here is generate a test case. And so this will execute, and as it's executing, it is collecting this information about this application and creating my test case for me. So if we go to the Host Explorer, under Project Explorer, you can see that I have my test case. And here's my test case has been created. It creates all of the interfaces. So these are two subprograms that I call, as well as any IO that I perform. It's built these interfaces for me, as well as the structures associated with it. So as you know, when you're creating these automated test unit test cases, these components have to be built, and normally they would be built manually. But this is the beauty of Topaz for Total Test. These components will automatically be created for us. Go ahead and take a look at the stubs. I'm going to reduce that. And here we have collected many of the stubs that this program performed. So we, as I mentioned earlier, we performed a call to this subroutine, and we did 6 calls. So we executed this call 6 times during the execution of this application. And with each call, we captured the details that was passed for that program. And you'll see here that we also have DB2 calls. So any updates that I performed, I captured that detailed. And you can see here that I've also captured or created the assertions. So right now we're asserting for this to be equal when we go and rerun this execution. I'm going to expand the SQL so you can see that we'll also show you the exact SQL statement that was executed during the execution of this particular application. In the Assertions tab, you can change this to have any value. So if you make changes and you expect this value to be higher the next time you run it, you can actually change the assertion to be greater than or less than or whatever it is that you're looking to test against. Right now, we default to equal. So in the test case scenario is where you would decide whether you want to use the stubs or the live data. So in this case, I've got all my stubs selected, so I'm going to virtualize all these components, both the subroutine calls as well as any of the I/O that this application is performing. If I decided to go with the live versions of any of these components, I would need to remove the stub and then provide that detail in the execution JCL. So now we're just going to go ahead and run this test case. Again, this is a DB2 application. If you're in a sysplex, for example, where you have one LPAR that has the subsystem defined to it and one LPAR that does not, we would have an affinity to that one LPAR. So we would always have to run against that one LPAR. Now that I've created this test case, however, because I'm no longer dependent on the DB2 subsystem, both LPARs become available for me to run my test case in, which is great because now I don't have to run in that one particular LPAR. Both LPARs are available and the workload can be shared amongst the systems. Oops. Okay. Hang on a second. So let's go ahead and run this. Also notice in this dialog here, oh, hang on a second. Sorry. We also have the ability to collect code coverage statistics during this. I could have collected code coverage statistics during the Expediter debugging session. You may want to do that to generate a baseline for your code coverage stats. We can also do that as part of the test case execution. So I can elect to turn on code coverage statistics collection here and have that. You can also enable that during the Jenkins pipeline as well. So we're going to go ahead and run this. And as soon as this completes, it will bring up the report indicating whether or not this test case was a success. And here we have it was successful. And it shows us every field that we were testing against. This is doing the comparison of the assertions. And so if anything was off or the test case itself was a failure, it would be highlighted in red, and it would drive you to the area where the failure occurred, and it would show you what was the expected value as well as what was the actual value received. So at this time, I'd like to show you my Jenkins pipeline. So as I mentioned, this can actually be incorporated into the Jenkins pipeline. So when I check my code in, we use ISPW here. So when I check my code in, that can trigger this pipeline for me. And I'll go ahead and build that. And as you can see, what it's going to do is it's going to generate the code in ISPW, which is essentially compiling them. It's going to promote it up into the next level. I probably should have shown you that. Right now it's in the devs level, so the lowest level where I've checked out the code. And when this is complete, it will have been promoted up into the different levels depending on the results of the Jenkins execution. So it's going to then, once it promotes the code, it's going to then download my test cases from GitHub. It's going to execute the test cases. I have it configured to collect code coverage statistics, so it's going to collect those, and then it's going to go into the SonarQube analysis and check the code quality, and that it's going to take all of those statistics and run them through the quality gate to ensure that it meets the standards that we have set, or the toleration that we have set within the quality gate. So the code coverage statistics, the test case execution needs to be a success, and then the code coverage statistics. And once this is complete, you can then go to SonarQube, and we'll go into this one. And this is where you can see those overall statistics. And so I get to see my code coverage statistics, and if I need to see the source code, I can see here, and it will highlight what code actually executed versus what didn't execute, as well as the unit test cases. And so if I go into any of my test cases, I can then see any of the reports, and I can validate that my statistics were executed and the test case ran 100%. All right, and with that, I'll turn it over to Jim. Okay. Jim, are you there? Okay, so in summary, okay.
In summary, we had an overview of automated unit testing for developer productivity. Yvette led us through an overview of Topaz for total test and how that relates to agile development and DevOps. And then we had a demonstration of the key features of Topaz for total test. So if you need additional or looking for additional information, there are some links on the slide that will take you to a web page and a video that goes into additional depth on total test, Topaz for total test. I think now we have time for questions, and we've had several questions come in The first question is, the data stubs for a test. Can I change the data?
Yes. Once you've collected or generated the test cases and you have the stubs for those, you can alter any of the data. And this actually is a great example of, a situation where you don't have test data to exercise a section of code. You can actually alter the stubs to provide you with that content and allow you to test, those areas of your code. So yes, you can change any of the data within the stubs.
Okay, and then another question we have is, what is the difference between unit testing and functional testing?
So unit testing is an individual unit test with all dependencies associated with it, right? So you're testing a main program with the subprograms. Functional test is you're testing a slice of a functionality within an application, right? Maybe we just want to test a subprogram within this particular application. Functional testing gives you that capability.
Great. And can we add unit testing or functional testing into an existing Jenkins CI/CD pipeline?
Yes, both unit testing or functional testing can be added to the Jenkins pipeline for automation.
Right. And another question we have is, how can I share test cases across my team that is spread across time?
Well, this could be done in several ways. One of them is obviously the old traditional ways, which is shared drives. Topaz for Total Tests also gives you the capability of exporting and importing these test cases, so you can export it from one workbench into another workbench. And you also have tools like GitHub that allow you to upload test cases that can be shared amongst the team members within your development organization.
Great. And then once you have your baseline test cases, the code changes are made and the code is compiled, how will changes to the program be tracked when you read test cases?
Well, that depends. Yeah, potentially it depends on what are the changes that are being made, right? If you're changing a calculation routine, then the results in the stubs may be different than what you originally collected. And yes, that would show up as a failure or not match the actual or the expected value. Again, then you can change your assertions if you're expecting those values to be different.
Got it. And for code coverage, do you need to use Git?
No, you don't. As I showed you before, you can collect code coverage statistics throughout the test case process, right? So I can do it in Expediter, I can do it at the test case execution level, and I can also do it in the Jenkins pipeline as well. So it's not dependent on Git.
Okay. Another question we have, do we have to ensure we have the same bed in all regions?
Well, once you've created a test case, if you've stubbed out your data, then you no longer have that dependency on that, right? So you don't necessarily have to have the same test bed. Again, the stubs can be your test bed, and then you can run that on any OPAR available.
And another question is, how do you handle date logic on saved stub data? Is there a way to age it to current?
Yes. With Exchange and tools similar to date simulation, those can be leveraged both obviously in the expediter collection process as well as the execution of the test case. So you can use those tools in addition during the testing process.
Okay. And has Topaz for Total Test been rolled out for MP online transactions?
Yes, it does. So it supports IMS, both all of IMS, BMP, DLIs, as well as MPP transactions.
Great. And would you be able to store test cases in Bitbucket instead of GitHub?
Yes. Similar type tools allow you to create these or upload the test cases into those areas if that's what you're using for your storage of your artifacts or your test case artifacts.
All right. And are you able to make unit tests for transactions with Topaz?
If you're talking CICS and IMS transactions, yes, we do support CICS and IMS.
All right. And then is it still all or none for DB2 stubs?
Yeah. You either need to decide when you re-execute your test case whether you're going to use the subsystem or not. And it needs to be all the stubs if you do decide to use the stubbed data, because we can't have those threads partially opened during the test case execution. So yeah, it's an all or none for DB2, CICS, and MPP.
Got it. And do we need to have all source listing in the DDIO file to be able to record tests and create unit tests and stubs?
So for the unit testing, because you were leveraging Expediter, obviously you would have had to prepare your program for an Expediter debugging session, which is populating a DDIO file. So the answer is yes, but we also provide you with functional testing, which does not require that you prepare the program for an Expediter. So that would, for your functional testing, you wouldn't need to have a DDIO file for the member that you're debugging or testing.
Great. And I'm just looking at the time. We have time for one more question. If we don't get your question answered, then we will definitely follow up with you offline to make sure that it gets answered. Last question is, does it support IMS databases?
Yes, it does. It supports both batch and on DB/DC online batch IMS databases.
Right. Okay.
Thanks, Yvette. Thanks, Jim.
Go ahead, Janet.
I'm sorry. Thanks, Jim and Yvette, for a great presentation. We thank everyone for attending today's webcast, and this concludes today's presentation. Have a great day.
Bye-bye.